Welcome everyone. Today's topic is electrical potential energy of a system of a two-point charge, which is I taken from the chapter Electrostatic Potential and Capacitance. Let us see all these topics. So first is electrical potential energy on a system of a charge. Let me see what is actually potential energy means. So the work done on a point charge in a bringing it from infinity to a particular point in the electric field against the field is called as electric potential energy. I just want to elaborate over there. If we have a main charge or source charge, let's say Q. So Q have their own electric field which is radially outward in the nature if this will be positive. Now, because of this electric field, if another charge who is in again in the same in nature if I'm just taking a test charge which is a detective which is a detector, so they have a because test charge have a very less magnitude or negligible magnitude, because of that they have very small electric field which can't be do anything or do impact on the main source charge. But what will be happen if this charge wants to interact with this surface? This test charge will feel a repulsion. So, if we are bringing a particular charge from infinite to a particular point in the electric field, as you can see. So, against the electric field, the work actually have been done. If again we will try to enter this particular field, because of a repulsion, the force is applied on this direction. So we have to move against the electric field, or we have to do work against this particular force. That energy required, that is called electric potential energy. Hope I'm clear. So this potential energy have some kind of a nature. So electrostatic potential energy for two charges, as we saw in the first one, if which is taking two charges of a system in an external field. So what will be the behavior of a potential energy? Let us see here. So this is a particular axis which we call as a geometrical axis. Now in this axis at the origin point, we know the value of origin, that is 0, 0. If they have three particular points, 0, 0, 0, it will be have. At point A, as we can see, there will be a charge Q1 have and there will be charge Q2 have at the point P. From origin, the Q1 have a distance vector R1 and Q2 have a distance vector R2. Relative distance, they have a vector R1, 2. So let 2-point charges Q1, Q2 are at the points A and B, whose position vector R1 and vector R2 respectively. V1 is the potential at B due to Q1 and V2 is the potential at A due to Q2. So we know that V1 is equals to 1 by 4 pi epsilon naught Q1 by R1. Similar, we have a 1 by 4 pi epsilon naught Q2 by R2 for the potential V2. But work done is equals to, we know that V into Q. So V1 and Q2, because of this charge Q2, that charge 1 experience some work. So this will be V2 Q1. That means W is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R1 2. But work is done in the form of a potential energy. That's why we can say work done, which is equals to the capital U, which is a potential energy, is equals to 1 by 4 pi epsilon naught Q1 Q2 by R1 2. So electrostatic potential energy for two charges of a system in an external field, W is equals to U is equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R1 2. Similarly, for the three charges of system, the potential energy U is equals to U12 for charge Q1 and Q2 plus U23 and plus U31. That means 1 by 4 by epsilon naught, which is the same for all these charges. Q1 Q2 divided by R12 Q2 Q3 divided by R23 plus Q3 Q1 divided by R31. And this is the final result. That is, similarly multiple charges we have with this, where sigma is a summation symbol for the discrete summation. And here the value of I is less than j. That means if we just take the value of j2, so we have to take the I as a 1. Hope you understand the concept, how I'll just solve and get the result. So revise these things. Till that, take care. Thank you for watching this video.